We should be on page 199 to finish up 4.6. Okay. We are talking today about complex conjugates. The standard form of complex conjugates, if I have A plus BI, its complex conjugate is A minus BI. Okay, so the difference between those two is the subtraction or addition sign, right?
Yeah.
Okay. So if I have 3 plus 6i, its complex conjugate is 3 minus 6i. 7 minus 9i, 7 plus 9i. Okay, those are complex conjugates to each other. Okay. Yesterday, we worked with complex conjugates. We just didn't talk about the fact that we were doing it. We worked with 3i and negative 3i. That's like 0 plus 3i and 0 minus 3i. Okay, those are complex conjugates of each other. Okay, so also remember, we talked about this yesterday, these come in pairs, right? Okay, your imaginary solutions are always going to come in pairs. So, what they're going to do today is they're going to give us a list of zeros, and they're going to ask us to write a polynomial function using that list of zeros. However, we have to understand that if they give us only one of these, it always comes with a pair. Okay? We said that yesterday. They always come in pairs. So if they only give us 7 minus 9i, we are going to have to include 7 plus 9i as well. Okay, so I'll show you an example here. What?
I was going to ask, can you put, plus minus sign?
No. Because we're going to need both factors. Okay? Technically, yes, it is 7 plus or minus 9i. But we're going to have to split them up and use both factors. And I'll show you why. Okay, so this example says write a polynomial function f of least degree, meaning the lowest degree possible, that has rational coefficients, a leading coefficient of 1, and the zeros 5 and 1 plus I. So they want my zeros to be 5 and 1 plus I. Okay, well, what we just talked about, if one of my zeros is 1 plus I, another one must also be 1 minus I. So I'm going to go ahead and add that in. Okay. So when they say the least degree, what would the smallest degree be that I could have with this number of solutions? The smallest degree I could have is 3. Okay. Now, there could be other zeros, and it could be a higher degree polynomial. But they just want to know what is the least that I can do with just these factors. Okay. So we're going to take our factors. I know that if this is a 0, when I write the function, what would the factor with this be? If this is a 0, positive 5 is a 0, the factor is going to be what in parentheses? What would the whole set of parentheses look like? X minus 5. Okay, that's the factor that would give me this 0. Yes?
Since you make the 1 plus I, you do the conjugate or whatever.
The complex conjugate,
yeah.
Yep.
Why don't you do that for 5?
Because the 5 is not an imaginary solution. It's just a whole number. Yeah, I can graph that. It can be imaginary. Also, it's going to work. You're going to have to do it with, thanks Nate, with square roots as well. And you'll have a problem like that. So, for example, if you have the square root of 7, you're going to also have to include negative square root of 7. because when we do square roots, we know they come in plus or minus.
So like only radical things.
Radicals and imaginary numbers. Okay? Because I know from what we did yesterday, is it possible to have a graph that crosses at multiple different whole numbers? Yes. Or integers, I mean. Yes. Okay? I had 1, but I didn't have -1 when I factored this. Okay? But when I got 3i, I still got -3i. Okay? So, back here, my other set of parentheses, now this is one part that confuses people sometimes. This 5, I got to recalibrate this board. I'm not going to be able to handle this all class. That 5 that we had, everybody saw how we put it behind the minus sign, right? We had x minus 5. This 1 plus I is the same as this 5. Okay, so it's going to be, my parentheses here are going to be x minus 1 plus I. Okay, notice I put it in the exact same place I put the 5 at, because it's our number. Okay, it's our 0. It's always going to be x minus your 0. So over here, same thing. It's going to be x minus 1 minus I. Okay, and then what we're going to end up doing is we're going to multiply all this together. Okay, because we're trying to come up with a function, so we're going to multiply it all together. Now, what you can do here, and I'm going to double check this before I just tell you to do it. Okay, they don't actually do it how I would show you, so I'm just going to do it their way. Okay, but basically we're going to regroup this. Okay, this would be the associative property. I can group these differently and multiply them, and it all comes out the same. Okay, but what they showed in your book is they actually took this minus sign and distributed it. So they ended up with x minus 1, and they grouped that, and then minus I. I distributed my negative sign and regrouped. I took my negative here and my negative here. You with me? Okay. Did the same thing over here. Bless you. So I have x minus 1 plus I. Okay. And you will probably notice, would you have gotten the same groups of parentheses if you'd have just taken these parentheses, regrouped, taken these parentheses, regrouped?
Yeah.
Yeah, it would have just been like that. What other way? How would you regroup it?
Yeah.
I just did. Look, I took these parentheses, I slid them over. I took these parentheses, I slid them over. It ends up the same thing as if you were to distribute it. Okay, so however you want to do it. And I still have this x minus 5. Okay. Now here, instead of dropping these parentheses and multiplying everything out, okay, I have x minus 1 how many times? Twice. That's the same as x minus 1 squared. Okay. And then I have I times a negative I, which is negative I squared. And then I have x. Right, because I squared is equal to what? Negative 1. So a negative I squared is positive 1. I'm going to do that in another step. So I'm going to do x minus 5. Now, this, I'm just going to put a bracket here. X minus 1 squared, That's x minus 1 times x minus 1, right?
Mm-hmm.
And then, like Damien said, plus 1. So I need to FOIL this out, and then add 1. Okay, so let's go ahead and FOIL this out. So x times x is x squared, x times negative 1, negative 1x. On the inside, negative 1 times x is another negative 1x for a total of negative 2x. Negative 1 times negative 1 is positive 1 plus 1. Go ahead, Peyton.
Where'd you get that first positive one?
This,
Yeah.
I squared is equal to negative 1 times a negative is a positive 1.
Okay. Yeah.
Good? Okay. So now, x squared minus 2x plus 1 is x squared minus 2x plus 2 times x minus 5, right?
Mm-hmm.
Now, you guys do it how you want. I like to when I multiply, I don't like doing it long or horizontally. I like to do it vertically. So if it were me, I would reline these back up. Just that way everything comes out and I don't have to be searching for like terms. Doesn't matter how you do it though. So negative 5 times 2 is negative 10. Negative 5 times negative 2x, positive 10x. Negative 5 times x squared, negative 5x squared. X times 2, x times negative 2x, x times x squared. We add. So I have x cubed minus 7x squared plus 12x minus 10. Good. Okay. So I wrote it as the smallest degree. I had 3 zeros. So the smallest degree it could have been was third degree. Okay. I wrote it with the zeros that it gave us. And it also wanted a leading coefficient of 1. Did that work? Okay. If they would have wanted a leading coefficient of 5, I would have gotten to this point and I'd have multiplied everything by 5. Okay, because then if you were going backwards, you could just factor that 5 back out and it wouldn't give you any solutions because you could divide everything by it. Okay? So that's the first thing I have for you for today. Okay, it's writing functions of least degree given some zeros. The next thing I have for you is at the bottom of page 200, Descartes' rule. I don't know if I'm pronouncing that right, but okay. What this is going to allow us to do, it's going to allow us to look at a function and figure out the possible numbers of zeros and how many real there might be or how many imaginary there might be, how many positive real, how many negative real. Okay, so I'm going to read through this and then we will talk about what it all means. Everybody on page 200? Okay. The first bullet they have there says, the number of positive real zeros is equal to the number of changes in the sign of the coefficients of f of x, or is less than this by an even number. And the second bullet says the number of negative real zeros is equal to the number of changes in the sign of the coefficients of f of negative x, or is less than this by an even number. Okay, there's a lot of words there. All that means is that the possible positive real zeros, I'm going to take the function and see how many times my signs change from positive to negative as I go through. Okay, and we'll do this in a second. Okay, at the end of that sentence, it says, or is less than this by an even number. So let's say the sign changes 5 times. Okay? That means there could be 5 real zeros. Or there could be 3 real zeros, because it's less than that by 2, which is an even number. Or there could be 1 real zero, because that's less by 4 or less than 3 by 2. Okay, everything's even numbers. It couldn't be 4 possible real zeros, because that would only be 1 less than 5. Okay, so we'll go through this, and hopefully it makes more sense once we start throwing a chart together here. So the example that I want to do, they give me f of x equals 2x to the 6th minus 5x to the 5th minus 3x to the 4th plus 3x cubed plus 10x squared plus x minus 9. Directions say determine the possible numbers of positive real zeros, negative real zeros, and imaginary zeros. Okay. So if I were to make a chart here, which we're going to, I'm going to have positive real zeros. I'm going to have negative real zeros. I'm going to have imaginary zeros. And then there's always going to be this column of total, because every function has a limit on how many zeros there can be. What is the limit in this specific problem? 6. Okay, you can't have more than 6 zeros in this polynomial because you have a 6th degree. Okay, so I can already fill in over here. I know my max total is going to be 6. So my total between my positive plus my negative plus my imaginary can only add to 6. We also know that my imaginary zeros come in pairs, right? So keep that in mind. They're only going to be 2, 4, 6, 8, only going to be even numbers over here. Okay, everything's coming in pairs. So to find the possible number of positive real zeros, I'm going to start here and I'm going to look at when the sign changes. So I go from a positive to a negative. There's one sign change. Then I go from a negative to a negative. That's not a sign change. And then I go from a negative to a positive. Now I've changed sign twice. Positive to positive, positive to positive, positive to negative. So I change signs how many times? 3. So it is possible that there are 3 positive real zeros. It is also possible that there is 1. We'll have to go do negative different. For positive, it's possible that there is only 1, because that's less than 3 by an even number. Okay, so 3 minus 2 is 1. So it's also possible there's only 1 positive real. Okay. Now at this point, I can't fill in any of this information because I haven't went through and done the negative. Okay, this was the first bullet point on your core concept. We just did this. Okay, that's my possible positive numbers, 3 and 1. Now to find the possible negative, we have to go through, and I am going, instead of f of positive x, I am going to use f of negative x. Which means everywhere I see an x, I'm going to actually change it to a negative x. Okay? So I'm going to have 2 times negative x to the 6th. Negative x to the 6th power is what? Just x to the 6th power. So that one didn't change. Correct? And then I'm going to have minus 5 times negative x to the 5th. Well, negative x to the 5th is negative x to the 5th. Because when you take something times times itself an odd number of times. If it's negative, it's going to stay negative. Times a negative 5 is a positive 5x to the fifth. So that changed, instead of being a minus 5x to the fifth, it changed to a plus, right? Okay. Now I'm going to minus 3 times negative x to the fourth. Negative x to the fourth power is x to the fourth times a negative 3 is still negative 3x to the fourth. Plus 3 times negative x cubed. Well, negative to the third power is still negative. Times 3 is negative 3x cubed. Plus 10 times negative x squared. That's going to go positive, which is not going to change this sign. So I have plus 10x squared. Instead of a positive x here, I'm going to have plus a negative x, which gives me minus x. And then my minus 9 is not going to change. Thank you for your input. Okay, so now this is going to give us the number of possible negative real zeros. So I have positive to positive, positive to negative, there's one sign change. Negative to negative, negative to positive, there's 2. Positive to negative is 3, and then negative to negative is not an option. So how many possible negative real zeros are there? 3 or 1. Okay. Now what you have to do is you have to go back and make sure you have every combination of these two numbers. Okay, so I have a 3 and a 3. I could also have a 3 and then a 1. I have a 1 and a 1, but I could also have a 1 and a 3. Okay, so obviously the higher that number gets, the more options, the bigger your chart's going to be, right? Okay. Now, regardless of what all this says, is it possible to have more than 6 total zeros? No. So I know all of these are going to have a total of 6. So here I have 3 and 3. So how many imaginary is there? 0. I have 1 and 1. There's 4 imaginary. 3 and 1 would give me 2. And 1 and 3 would give me 2. Then you have your chart all filled out. Okay. I will leave this on the board, and hopefully I got through it fast enough where you guys can have some work time and ask questions. But I will leave this part on the board for you. Yeah, here's what I was looking for. If you have questions, make sure you let me know as you're going through your assignment. Yeah, Gage? I got this 4 on the imaginary because 1 plus 1 is only 2, and I know it has to add to 6. So there has to be 4 imaginary that we're not seeing then. Yes?
Those are going to be like problems, are they? Like, where we have to make the chart. Like, are we going to have to make this on our homework?
Yeah.